In this lesson, we're going to solve problems, solve these polynomial style equations, even though if you quick glance on here, number two has a monomial here that is, or at least a term that is not a monomial. So it would be incorrect to even call something like number two a polynomial. However, we can convert it or treat it as a quadratic. So these will convert them to quadratic form. All of these would be converted to quadratic form, and we can solve them with our quadratic techniques. So to be in quadratic form, that's ax squared plus bx plus c equals 0. So if we can make it look like that, we can usually factor it or solve it in some other way, our quadratic techniques. So what you do need to have to make quadratic form is 1, 2, 3 terms, where the first two terms right here have x to the first power, and in the first term would be x to the second. So those two things are critical, and then we'll have a constant sometimes. But to be quadratic, the variable on x has to differ by a degree of double. Okay, this is degree 1. The first term is double that, or degree 2. So this first example is complex looking, but this binomial right here is degree 2 in the first term and is degree 1 in the second term. And then we have a constant. So that is in quadratic form. You can make it look a little bit simpler if we use a technique called substitution or use substitution. If I introduce a new variable, I'll just say let this new variable u equal that binomial 3x minus 2. So in the given problem, we've got 3x minus 2 squared. If I substitute for u, that'll say u squared. In the second term, I've got 3x minus 2 to the first. If I substitute, that'll be minus 5 times u. And then I got the minus 6 equals 0. It just converts something that's fairly complex looking to something that's not so complex. You're used to treating these quadratics. This is quadratic now. You can solve it any way, any quadratic way. Luckily, I think this one will factor u, and it'll have to be a negative 6 and a positive 1. So if we solve that for u would be 6, or u could equal negative 1. But these aren't solved until we resubstitute. Go plug this back in for u in both places and say 3x minus 2 is 6, and 3x minus 2 is negative 1. And solve both of those for x. U just helps us to get to x. So 3x equal 8. X is 8 thirds. 3x equal 1. X equal 1 third. And we finally solve it for x. So the technique is convert what looks complex to a quadratic that does not look complex, and we can solve it. So we use that u substitution to do so. So let's see if number 2 has the same situation. Is this and this, do they differ by a degree of 2? Well, whether you know it or not, the square root of x is the same as x to the 1/2 power. If I were to use a exponent to express that, that'd be x to the 1/2. So that middle term has an exponent of 1/2. The first term has an exponent of 1. So they do differ by double. Okay? You have to double x to the 1/2 in order to get x. So we can use u substitution. Let u be the square root of x. and rewrite it in terms of u. So the first term would be u squared, the next term would be 6u, and the next term would minus 7 equals 0. That solves rather easily. U minus 7 and u plus 1. Solving for u, positive 7 and negative 1. Don't forget, we got to resubstitute now. We're not interested in u, we really want x. So u is just a step along the way. If I plug that back in, I get the square root of x equals 7. The square root of x equals negative 1. Square both sides to isolate x. I get x equal 49. If I square both sides, I get x equal 1. Or do I? Look at that second solution. The square root of x, take away that 2. The square root of x equal negative 1. The square root of what number is negative? Well, that's not possible. Okay, you can't take the square root of a number and get a negative number. So this one has no solution. The only solution is 49. Example number 3. We look again. There are 1, 2, 3 terms. And the degree on that middle term, the degree of the variable is 1. And the degree of the variable in the first term is a square. So that's double the middle term. It can be written in quadratic form. We'll do that u substitution. We'll let u equal the absolute value of x. So that first term would become u squared, the middle term, 11u, and the constant, and 0. And we can easily write a quadratic. Once again, I think this was going to factor. Like 8 and 3 will take care of it. Minus 8, minus 3. So solve each of those. U is equal to positive 8 and u is equal to positive 3. Don't forget, now we have to back substitute the absolute value of x for u in these two expressions. So the absolute value of x equal 8. So x equal plus or minus 8. The distance from 0 is 8. So you could be positive 8 or negative 8. Or the absolute value of x equal 3. So x equal plus or minus 3. Example 4. We've got, like we did before, there's 1 term, 2 terms, 3 terms. To write it in ax squared plus bx plus c form, we'll just take that binomial right there. It's got a degree 1 right here. It's got a degree 2 right there. So we can write with u substitution that u equal that binomial, x squared plus 6x, and substitute it. That first term becomes u squared. The next term becomes 9u. And we make a simple quadratic out of something that looks complex. This one, I believe, factors, though I haven't tried it. U here, u there. How about a 4 and a 5? Plus 4 plus 5. So u equal negative 4 or u equal negative 5. Let's back substitute this expression right here for u, that u was x squared plus 6x equal negative 4, 6x. Or x squared plus 6x equal negative 5. Now we have two quadratics again. We solve quadratics by getting set equal to 0. X squared plus 6x plus 4 equals 0. But x squared plus 6x plus 5 equals 0. Now this one on the right, I could solve, I think, with factor techniques. X and x, 5 and 1, plus plus. So x equal negative 5, or x equal negative 1. That first one doesn't look like it factors. I don't think it does. So I'm gonna use complete the square. Again, we can use any quadratic technique. I put in that space half of 6 squared. I put a plus 9 here and here. So this factors, this trinomial factors as x plus 3, which is x plus 3 squared, and that is 5. Take the square root of both sides. X plus 3 equal plus or minus the square root of 5. So x equal negative 3 plus or minus the square root of 5. Now your assignment has, I'm going to go to it, the assignment has 4 problems assigned, but I've asked you to skip number 1. Number 1 involves negative exponents, and we haven't defined that well, haven't done enough with negative exponents, so I'll skip that one. So you only have 3 homework problems to do. You should be able to set up each one as a quadratic using a U substitution. Email me if you have any problems.